Yay! Chapter 16 is also easy, just like chapter 15. If two figures are similar, what can you determine about measures of corresponding angles and lengths? And before I waste your time and go over everything, let me just tell you, simply put, what they're trying to teach you today. And yeah, you have to scroll down all of this stuff. As you can see, I always preview everything before I record. So just go over the online textbook. There are no mistakes as far as I can tell in this section. So everything seems fine. But anyway, I just want you to remember something. Remember we learned about dilation? So what's the rule for that? When we have x comma y, we're basically multiplying the same number to the x and the y. So in this case, we are blowing up a shape by a factor of 2. So in other words, if I had a little square, it's going to now become a square that is twice as big. And so in this case, we called it what? Similar. And so basically, this is section 1 and 2 combined. In section 3, now we're going to talk about the angles and the side lengths. But we already learned this in dilations, and when two shapes are similar to each other, we talked about how the angle measures are the same. So you see these four angles, this one, this one, this one, and this one, they're all 90 degrees, and it is going to be the same measure in the bigger shape. Or even if you went from big to small, okay? The four angle measures should always be the same. Another thing that they want to teach you in this section is that the ratio of this side to this side is obviously going to be 2 because it's 1 to 2, right? But that should also be the same for the other side, from this side to that side, 1 to 2. Same for this side, 1 to 2. And same for the other part, 1 to 2. Okay? So that is basically what we are learning today. All right? So go down, take a look at this, learn this stuff, and let's see. So over here, what they're trying to teach you is that these two triangles are similar to each other, which basically means when you went from shape triangle ABC to XYZ, you made it a little bit bigger. So this is a dilation. If they are similar to each other, and for that they use this squiggle over here, and so you write it like this: triangle ABC is similar to triangle XYZ. Now the order in which you write the letters is really important because you gotta remember, you see the ratio over here? Just first remember that the three angles have to always measure the same over here. Angle A, angle X. So these two angles have to measure the same. And then B and Y. These two angles have to measure the same. And C and Z, these two angles have to measure the same. Another thing that you have to remember about similar triangles or any kind of similar shapes is that the ratio of sides are always the same. So as you can see, side AB, the ratio of side AB to XY should be the same as, because we're talking about ratios, we're not talking about the exact same measure because it cannot be the same because then those two shapes would be congruent, right? We're looking at similar figures, so the angle measures are the same but the side lengths have to be different because similarity is all about blowing up or shrinking a figure, okay? So just keep that in mind. And then BC, the ratio of segment BC to YZ has to be the same, okay? And also AC to XZ. So when you just look at this, you think this is no big deal, but really, you gotta remember, AB, the first two letter, goes with XY. You see that? And you see how ABC all has to be on top, and then XYZ all has to be at the bottom. And then when we talk about BC, then those go with, BC goes with YZ. And then you see AC over here, I used the two dots, it goes with XZ. Okay, so there you go. I always use these alien symbols when we use triangles. Okay, when these two are similar to each other, then we always go these two together, those two together, and then the two dots together. Okay, this is like an easy way to remember when you have triangles. So those segments go together, and their proportion has to be the same. And then the angle measures of A and X has to be the same, B and Y has to be the same, and C and Z have to be the same. And if you scroll down, you can actually see I already submitted the answer, so it's kind of like you cheating, right? But figure ABCD maps to figure LMNO, and they are similar to each other. So what would AB go with? AB is the first two letters, so it will go with the first two letter here, which is segment LM. So make sure you put that there. And then of course, LO is the first and the very last, so you have to look for the first and the very last two letters, and that's AD. Okay? So which angle must be congruent to angle C? So angle C is the third letter, so the third letter here is angle N. So I went ahead and put angle N. So you get the idea, right? Okay. Corresponding angles have to measure the same, and corresponding side proportion have to measure the same. I got question number 1 wrong over here. So let's make sure that I explained this to you, right? So anyway, let's take a look at the question. Well, I'm showing you the answer as well. Triangles. So first of all, we have triangle PQR and triangle LMN, and they are similar to each other. QR is 4 and MN is 14. Okay, so since they already told us that these two shapes are similar to each other, we know that angle P should be the same as angle L. Angle Q should measure the same as angle M, and angle R should measure the same as angle N. But they're not asking about the angle, right? They're talking about segments. So again, QR is the last two letters in shape PQR, and so is MN. So we know that we are using the correct corresponding sides. The ratio is basically going from 4 to 14. So are we going bigger or smaller? Bigger, right? So then is it going to be 4 over 14, or is it going to be 14 over 4? Let's think about this, right? So we're going from small to big. That means if we simplify this, this is 2 over 7. If we simplify that, this is going to be 7 over 2. What do you think is going to give you a bigger size? I told you any number, if you want to blow it up, you have to multiply it by a number that is bigger than 1, which is 7 over 2, because that's 3.5. 2.7 is a decimal smaller than 1, so that means you're shrinking, right? So that's how I got 7 over 2, just by using the ratio, okay? So then what is the rule? Well, the rule is x comma y is now basically being blown up by 7 over 2 in decimal form is 3.5. So it's 7 over 2x and 7 over 2y. So that is basically what it is, because similarity is all about dilation, and we talked about dilation. Dilation means you basically blow up a size, and so the x and the y both have to be multiplied by the same number. Remember that? And so this is a very easy question, as long as you understand that corresponding angles have to measure the same, and corresponding sides are going to have the same ratio. You just have to know, are you going from here to here, or here from there to there? So you got to read the question really carefully. Okay, so then the next question, I already got this question right, but triangle DEF and UVW are similar. Is the following true? Well, so let's see. Triangle DEF and triangle UVW is what we have. And look, we have DE on top, that's the first two letters, so then at the bottom should be UV, the first two letters, right? And those two ratio has to be the same as the other segments. And so on top, that is the problem. We have VW and EF. So these two segments are correct, but what do you notice over here? Everything has to be on top. So if you have DE on top, the EF also should be on top. And so everything on this side, if it comes first, they all have to be on top, or everything over here has to be at the bottom. But over here, they switch sides. Okay, they switch sides. And therefore, I said the proportion is not true, and that is the correct answer. So if you move on to the very last part, okay, they actually make it a little bit more complicated for you. Okay, so they give you two shapes, and then they try and make you find out what y is equal to, what x is equal to. So what I'm gonna do is I'm gonna go straight into the your turn question. okay? Because that's the easiest way for me to explain this. And after this video, this question, I'm gonna be done. Let me make this a little bit bigger for you so you can see better. Okay, so it says use the diagram in which triangle ABE is similar to ACD. So they already gave you the order. And it says find the value of X. Okay, so I don't have to worry about Y right now. I just have to find the value of X. Okay, so then that's the angle right here. So that's angle B. So I just got the measure of angle B right here. That's the letter in the middle. So which angle do you think should measure the same as angle B in triangle ACD? Yes, angle C, because that's the letter in the middle. So what is angle C, by the way? Oh, 50 degrees. So 4x plus 6 has to equal 50. Now from here, it's very easy. You subtract 6 from both sides. So 4x is equal to, what's 50 minus 6? 44. Then we divide both sides by 4. So x is now equal to 11. So your answer is 11. So as you can see, if you just understand that corresponding angles have to measure the same and corresponding sides need to have the same measure, same ratio, same length ratio, then you are good. Now let's see what the next question has for us. Oh, of course, now this time it's going to tell you to find the y. And so the y is right here. So let's see, if this is 6.8, then only this should be y, right? Okay, so let's take a look. Again, these two same triangles are similar to each other. So if I want to find y, we have A, B, E, and A, C, D. So we have to think in terms of the big triangle and the small triangle, so I can't just think in terms of y. Okay, so what would be the side that goes with AD? Because AD includes the y. So AD would be the, let me just go back to using my regular alien symbols. That would be the first dot here and the bottom dot. Okay, so then it's the first letter and the third letter. So what about over here? The first letter and the bottom letter would be AE. So we're looking for the ratio between AE and AD. So AD is this whole thing. That would be 6.8 plus y. Okay, and so the ratio of that over, because it doesn't matter which one goes up, but I'm doing AD first instead of AB, okay? So I'm going back and front. But it's up to you. You can do front over back, but I'm doing back over front, okay? And then the corresponding side was what? AE. So what's AE? Oh, I get 6.8. And this ratio has to be same as any of the other sides. So you know what I'm looking for, since I already got my answer for x, but I'm not gonna look at that angle. I'm looking at another side. So I can look at DC because I started with the back one. So DC is this one right here, and DC is 5 centimeters. So what goes with DC or CD? The last two letters. Yeah, BE. Okay, so what is BE? Oh, it's 4 centimeters. So that's my ratio. Okay, in case you forgot how to calculate this, you have to go ahead and use the cross multiplication method. So you go 5 times 6.8 is equal to what? 4 times everything here. 6.8 plus y. Okay? So then, of course, you're going to need a little bit of a calculator and all that stuff. But 5 times 6.8 is, so it's 34, and that equals, that would be 27.2 plus 4y. So of course we're going to subtract 27.2 from both sides, and I don't have space down here, so I'm gonna go here even though that's not really a good idea. So 34 minus 27.2 is going to be 0.8, and then 13 minus 7 is 6, right? Okay. And that equals 4y. And then you divide both sides by 4, so y is now equal to 1.7. So the value of y is 1.7. So if you're confused with the calculation bit, it's okay, because in the classroom, I'm going to give you a similar question to this one, because I understand how this section is easy, but you might be rusty on the algebra. So anyway, my answer was 1.7. Let's make sure that we check our answer before I get done with the video. And that was right. Okay, so have a great day. I'll see you in class tomorrow. Goodbye.